So here's problem number 41 from section 4.4. And here's the idea, is that as we go along this curve, the curve of x or y is equal to square root of x, the distance between a point on that curve and the point 3/2 0 changes. The question is there a point in which the distance is at a minimum? Now, to do this problem, we would really want to use the distance formula, x1 minus x2 squared, y1 minus y2 squared. That is our formula for the distance between any 2 points. And that distance, well, one of the 2 points is 3/2. One of the 2 points is a point on this curve, which is in the form x comma square root x. So we get something like x minus 3/2 quantity squared plus the y values, which is root x minus 0 quantity squared. And there's our distance formula, and that's the thing that we want to minimize, so that's the thing we have to take the derivative of. But they drop a big old hint on us to make our lives easier. Here's the idea. While it is true that we can take the derivative of d and find our path to the solution, an insight is that if I can minimize the stuff that's underneath the radical sign, of course that stuff has a special name, it's called the radicand. If I can minimize the radicand, I will have minimized the function. So instead of taking the derivative of little d with the square root and the squares, I create a brand new function and I call it big D. And big D is only the radicand. And I'm going to minimize that function. If I minimize big D, I will have minimized little d as well. And I've created a function.
I know, I'm sorry. I know. I'll do it.
Okay. All right. All right. So if I minimize big little d, I'll be okay. And that derivative is easier to take than the other one. So let me do that. The derivative of, well, actually, let's do a little bit of cleanup. X squared minus 3x plus 9/4 plus x. I expanded. So x squared minus 2x plus 9/4 is big D. D prime is going to be 2x minus 2. Set that equal to 0. It looks like x is equal to 1. Now again, please compare me taking this derivative as compared to taking that derivative. Okay? All right, now, we found the x. How close does this curve come? Well, we've got the x value. We're told that x is 1. The y value would have to be 1. In order to finish the answer, we have to go back to our original equation and say, well, the distance is the square root of 1 minus 3/2 quantity squared plus 1 minus 0 quantity squared. Or the distance is 1/2 squared plus 1 squared plus 1, or we get the square root of 5/4. Or maybe that's the square root of 5 divided by 2. Oh, and there's the answer, square root of 5 divided by 2. So we must have done something. Look at that. All right, we're good there? All right.
So we're just looking for the distance?
Well, we answered the question. How close does the curve get to? That's the distance. Is the length of the little pink line when the distance is minimized. All right.